Okay, hi everyone. Welcome to this algebra review portion of Math 140. Um, and we're going to cover some basic concepts of algebra to get you started with this applied calculus course. Okay, so before we get started with any heavier material. So some of the learning objectives today for this algebra review session are going to be perform basic operations of algebra, understand variables and algebraic expressions, solve equations and factor polynomials, be able to recall key concepts of functions and graphs, and simplify exponents and rationalize expressions. Okay, so let's get started with this first concept, which is basic operations of algebra. Okay, so before we start with any type of algebraic concepts, one thing to always remember in the back of our mind is the idea of PEMDAS, this order of operations. Okay, so PEMDAS is an acronym, right? If you kind of remember that from your high school and middle school, acronym for parentheses, exponents, multiplication, division, addition, and subtraction. Okay, so when you're trying to solve some type of math problem, you always have to follow this PEMDAS order of operations. So that means you take care of the parentheses first, then you take care of exponents, then multiplication and division, then addition and subtraction. Okay, so in that order. So, let's refresh our memory a bit. Let's take care of this example right now. So we have this example, 3 squared plus 4 times 8 minus 5 divided by 6. Okay, so if we're going to follow PEMDAS, right? Well, what comes first? P, parentheses, right? So I have this 8 minus 5 in parentheses here. And so I'm going to focus on that. So that'll be 4. 8 minus 5 is 3. Let me rewrite this. And then divided by 6. Okay, so we took care of parentheses first. Now let's check out some exponents, right? So I have exponents. So I have this 3 squared. So let me take care of that now. So 3 squared is 9. 4, 3 divided by 6. Okay, so take care of exponents. Do we have any multiplication going on? Yeah, we have this 4 times 3. Okay, so 9 plus 12 divided by 6. Okay, and now we have D, division. We do have a division going on. 12 divided by 6, and that is just 2. And lastly, addition. We have 9 plus 2, and that just equals 11. Okay, so no subtraction, but this kind of just goes along the same lines as that. So just a little bit of refreshment on PEMDAS, okay? All right, so let's move on to fractions, right? So, you might be familiar with this, it might be a little shaky in your past, but let's go ahead and refresh it and kind of get on the same page a bit, okay? So let's see how we can add, subtract, multiply, and divide these fractions, okay? So if we look at example A, right, we have 2/3 plus 1/3, right? We have the same denominator, right? So when we have the same denominator, we can just combine the numerator terms, right? So since we have the same denominator, we can write something like this, 2 plus 1 over 3, right? And this would just be 3 over 3, and then 3 over 3 is just comes 1, right? So kind of remember that a little bit. But we have the same denominator, so we can just worry about the top. And likewise for part B, right? We're subtracting this time, but we have the same denominator, which is 7. So once again, all we got to do is worry about the top. So this would just be 4 minus 1 over 7. And this would just be 3 over 7. Okay, so same denominator, not too bad. So let's focus on some multiplication now, right? We have 2/3 times 1/3. So when we're multiplying fractions, we got to worry about multiplying the top and the bottom. So what this really becomes is 2 times 1 over 3 times 3. So this would just be 2 ninths. Okay. And now what about dividing though? So dividing is when it gets a little less straightforward, but then again, it's like the same thing over and over. So 4/7 divided by 1/7, what that really is just 4/7, and you reciprocate whatever you're dividing by. So this becomes 4/7 times 7/1. We flip that fraction over on its head. And then it's just multiplying this fraction out. So this just becomes 4 times 7 is 28 over 7, right? And that just simplifies to 28 divided by 7, which is just 4. Okay, so that's dividing fractions. Remember, when you're dividing it, you just flip it and then multiply it. Okay, so if we look at part E now, what happens if they're not the same denominator and we're not multiplying or dividing it, right? So here's the case where we got to find um, we got to get the same denominator, right? So if I want to get the same denominator, if I look at these two terms here, I have a 2 and a 4 on the bottom. Well, I know that if I multiply this denominator by 2, then I'll get 4, and then I'll get the same denominator on the bottom. So let's do that. So if I have, I'm going to write this right here. If I have 1/2 times whatever due to the bottom, I got to do it to the top, plus 3/4. I'm not doing anything to the 3/4 because I'm trying to get that denominator to be 4. So if this happens and it's just 1/2 times 2/2, that just becomes 2/4 plus 3/4. And then we're just going to worry about the top now because we got the same denominator. So this will be 5/4. And there you go. And likewise, you would do the same if you were subtracting, right? Just try to get the same term, same denominator. Okay, so just a little refreshment on fractions, right? How to deal with them. Okay, so that takes care of our first concept, right? So let's jump to our second concept, which is variables. Okay, so I know you might have had some trouble with this in the past, you might have not, but let's go ahead and try and go over it right now. So another very important thing in algebra and going into calculus is this concept of variables, right? So what is a variable? So a variable is a quantity that can be changed and is not fixed, right? It's some arbitrary generic term, right? So in simpler terms, a variable is just a letter, right? That represents some type of unknown number. Okay. And these letters can be X. We're going to be consistently using X, Y, and it could be A, it could be B, it could be any number, right? Maybe even be a Greek letter, but we'll try and keep it a little toned here. But some ways these variables are used are in like these expressions, right? As y equals 3x plus 2. Maybe you remember some type of function of that form. Something like 3n plus 1 over 6n minus 2, and something like 5a plus 3, right? So, along with these variables, right, it comes into having to simplify these, right? Sometimes we might get some crazy expressions and we have to simplify them using like terms and simplifying some constants, right? So let's check out some examples and see exactly what we mean by simplifying algebraic expressions. So if we look at A here, right, we have 5 times 3x plus 6, right? See, we have this variable here, x, and we're just going to try and simplify this out. So what we do here is the way to simplify is you have to distribute in this 5, right? If we want to get this as simplified as it can be, we have to distribute this 5, and that means you're going to multiply it to each term. So what this ends up being is 15x plus 30. And that's pretty much all we can do. So we're good there. Okay, so let's check out part B. So part B is 2x plus 2 plus 7x minus 4. You know, what this really is just 2x plus 2, and this is just plus 7x minus 4. We have like terms here, this 2x and 7x, and this 2 and negative 4, and we're just going to combine these like terms, right? So don't worry about the x, right? It's not going to be like x squared or anything like that. We're just combining these. Just worry about the number attached to it, right? So this would just be 2 plus 7, and that would just be 9x, right? The x stays the same. We're just worrying about the number in front of it, the coefficient, if you remember that word. And then we have 2 and negative 4, so that would just be 9x minus 2. All right? Okay, so let's check out part C. So here we have a situation where it's minus this expression in parentheses, right? So what you always have to do first is take care of this minus. You have to distribute in this negative because it changes it. So it'll be x plus 3 minus 6x, right? And negative times negative 1 is going to be positive 1. Okay. And so you once again combine these like terms and you should get x minus 6x, right? We just worry about the coefficient, be minus 5x, and then it would be plus 4. Okay, great. Now let's check out part D. So part D, we have 4x minus 1 plus 2 times x minus 1. So same thing, we got to distribute in this 2. Okay, so we will have 4x minus 1 plus 2x minus 2. And we're going to combine like terms, 4x and 2x. That becomes 6x. And then we'll have negative 1 and negative 2. And that becomes negative 3. Okay. So we have this last one here, this 2x plus 3 times 4x minus 3. So now we're not adding a subtraction. We're actually going to multiply out these two expressions, right? So this is called like foiling, right? Where you have to distribute it to every single one. So this 2x is going to multiply 4x. So this wouldn't be 6x, right? Because we're multiplying it now. What it would be is 8x squared. 2 times 4 is 8, and then x times x is x squared. Okay, so we're not done yet though. We have to multiply everything to each other. So now this 2x is going to multiply negative 3, and that would be negative 6x. Okay, so that was just as 2x. Now I have to distribute in this 3. So this would be 3 times 4x. This would be plus 12x. And then this 3 times negative 3, and that would be negative 9. All right, and so we're going to simplify this. This would be 8x squared. Only things that can combine is this negative 6x plus 12x, and that would be like 12 minus 6, so that would be 6x and minus 9. Oops. All right. Okay, so that is a brief review about simplifying algebraic expressions, right? Distributing, adding, multiplying. So hopefully that jogs your memory a bit. Okay, so now let's go into solving equations, okay? So we've been introduced to variables and expressions, but now what if we're asked to solve an equation? Okay, so what does that mean? So what if we have some type of expression that is like 4 equals 3x minus 2, right? And we're being asked to solve the equation. Well, what that means is I want to figure out what value the variable x is, right? So that we have to perform some type of algebraic operations to get x by itself. And we're going to have like x equals some number, right? That's the goal. So let me kind of write that. Our goal is to get x equals some number. Okay, so let's do a quick example and see exactly what that means. So we have 4 equals 3x minus 2, just like above. And I want to figure out what x is. I want to solve this equation. So what I got to do is get x by itself. So we're just going to do some algebra. So I'm going to add 2 to both sides, right? Because I want to get this x by itself. So if I add 2 to both sides, I get 4 plus 2 is 6. And this is going to be, this cancels out, right? That's why we did that. It's going to be 3x, right? I still need to get x by itself. So what's the opposite of 3 times x? Or how about divided by 3? Okay, so we did that because that cancels out. And now what we have is x equals, use a different color. We would have x equals 2. 6 divided by 3 is 2. And that is solving the equation. Okay, so make sure if you're getting a little lost, pause the video, rewind it, um, you know, go at your own pace, okay? But that is solving the equation, okay? So now we're gonna be talking about functions and graphs, okay? So maybe in the past you've had some trouble understanding what a function is exactly, right? You know, this is always been a hard part of people to comprehend. So maybe just think of this example, see if it will help. So imagine we have some type of machine, right? And this machine takes in an input, does something to it, and then gives you an output, okay? So for example, let's consider you put in a number like 3 and the machine outputs a number 6, right? If you put in a number 5, it'll output a number 10. So this type of machine is what we call a function. Okay, so here's how it really works. So input, this is what you put into the machine. You could think about it as an input value or x, right? X is always our input. And the machine's rule is it's a rule that tells you how to transform the input into an output. For example, it might be the rules are multiply the input by 2. Okay. So output, and this is what you get after the machine applies the rule. Like after you plug in that input, machine does the rule, and what you get out is the output. So it would be your output value, or what we typically call y, right? Because remember, x is input and y is output. Okay. So if the rule of the machine is multiplied by 2, then if you put in a 3, then you'll get an output of 6. 3 times 2 is 6. If you put in a 5, multiplied by 2, the output is 10. Okay, and that will give you a function like f of x equals 2x. The rules are it's 2 times the input. That's the machine rules. And whatever number you get, that's the output. Okay, so just a couple to summarize this a bit. F of x is the name of the function. X is an input and 2x is a rule. So kind of going over and over again. So this is really just a way to talk about inputs and outputs with some type of, demonstrative example. But, think about X as your input, the 2X as your rule, and the Y as your output. Okay, so hopefully that helped. Read through this again if you need to, kind of watch it again. But let's go ahead and keep going forward. So we have this really sort of definition or refresher of what a function is, but you know, we're not going to be going through too many definitions of functions. We're just going to be working with them, right? And by working with them, what we're going to do is evaluate these functions. So, what does it mean to evaluate a function, though? What that means is just finding an output for a specific input. So, if I plug in an input, what's the output going to be? Okay, so like, uh, don't be afraid of the notation. That's what I would say, right? Don't be afraid of it. Just kind of understand, like, okay, this just means I'm plugging in two. What number am I going to get if I plug in two? Okay, so let's see. So if I have f of this just means like f of two. So what we kind of say it, f of two, that just means plugging in an input of two. So f of two, we kind of write it like this. So I'm just gonna plug in two wherever there is an x. Okay, so this just means 6 minus 7, which is just negative 1. So that's the output I get. So let me kind of write that output. Okay, great. So now let's check out part B, f of negative 2. Okay, so this just means I'm going to plug in negative 2, use a different color, wherever there's an x, right? That's what I'm doing. So negative 2, that means I'm going to get 3 times negative 2 is negative 6. So it'll be negative 6 minus 7, and that is negative 13. And once again, it is an output. Okay. So that's our output for 2 and negative 2. So do you remember XY coordinate points, right? Well, it's the same thing as an input and output. So from our previous example, we saw when you evaluate f of 2, we get the coordinate point 2, right? That's our input, and negative 1, our output. So input, output. Okay. So we could also write this XY coordinate point as such. That's the same exact thing. This equals negative 1. We see how the relationship is, how that works out, where this is our input and this is, it's actually sorry, that's a typo. It should just be, shouldn't be negative. It should just be 2. Okay, so make sure you fix that. Just gonna cross it out. Okay, so that's the relationship there, input and output. All right, so let's check out X and Y intercepts. Okay, so an x-intercept is the coordinate point of the form x comma 0. That just means that what's the x value when y equals 0? When there's no y value, it's just 0. Okay, and graphically speaking, it's when it crosses the x-axis. And similarly, a y-intercept is the coordinate point of the form 0 comma y, and it's the y value when x equals 0. when there's no value for x, and this is when it crosses the y-axis. So let's kind of take a look at what that might be. Okay, so if I have something like this, you know, some type of function like this, right? Some type of function f of x. This would be your y-intercept, and this would be your x-intercept, right? We're crossing the y-axis here, right? X has a value of 0, and we're crossing the x-axis here, and y has a value of 0, right? So it would look like 0 comma y and x comma 0. Okay, so that's a little bit of refresher about x and y intercepts, okay? We won't get too much into it right now, but that's sort of the general idea of it. Okay, so lastly, for this functions and graphs type of idea, let's refresh ourselves on some of the basic types of graphs with algebra. We're not going to go, since this is applied calculus, we're not going to go too deep into detail with all these graphs, but just get some general idea of what some of these basic graphs look like. So linear, if you recall linear functions, it's really just a line. So it'll look something like we just drew above, but it looks something like that. Maybe has a negative slope or something like this, right? Quadratic, if you recall quadratic functions, they're more of like a bell, upside down bell. They look something, you know, like that. It's called a parabola. Maybe it's upside down. And then cubic, really is, we probably won't see too much of it in this class, but just want to give you a general sense of it. It looks something like that. I could draw this a little better. Something like that, a little more curvy. These are kind of like basic graphs to kind of understand. Mainly linear and quadratic, just because of some applications that calculus could do with costs and revenue and profit and things like that. But okay. So join me for the next video and we'll finish the rest of this algebra review. Thank you.